This lecture is going to talk about reading and writing data in R. So there's a few different types of ways you can do this, and I'm going to talk about some of the primary functions that you use in R to read and write data. So there are a few principal functions that we're going to talk about for reading data into R. First two are read.table and read.csv. And these are for reading tabular data, and they're probably two of the most commonly used functions for reading data into R. These functions read text files that contain data that are stored in kind of rows and columns type of format and return a data frame in R. The function readLines is for reading lines of a text file, and so this can read any type of file really. It just gives you text in it as a character vector in R. The source function is important for reading R code. So if you have a R code, for example, functions or anything written to a file, the source function will read all that code into R. The dget function is also for reading R code files, but it's for reading R objects that have been what are called deparsed into text files. We'll talk a little bit more about this later. The load and the unserialized functions are for reading binary objects into R. So the analogous functions for writing data are write.table, write_lines, dump, dput, save, and serialize, and those kind of pair up with their reading analog. So the read.table function is the most commonly used function for reading data into R. And it's important that you know kind of how the arguments work, what the arguments are, and understand what they mean. So the first argument is pretty obvious. It's the name of a file or the name of a connection, which we'll get to a little bit later. Usually you're going to give this a file name. It's going to be a string, and it's going to be a path to a certain file in your computer. The header is a logical flag indicating whether the first line is a header line. So if the first line, for example, it has all the variable names in it, then that's not really a piece of data. That's just a line that has labels on it. So you want to tell the read.table function whether the first line contains the variable names or not, or whether the first line just right away contains data. The sep argument stands for separator. It's a string that indicates how the columns are separated. So, for example, if you have a file that's separated by commas, then the separator is a comma. Sometimes files are separated by semicolons or by tabs or by spaces, and so you want to tell read.table what the separator is going to be. Call classes is a character vector whose length is the same length as the number of columns in the dataset, and the character vector indicates what is the class of each column in the dataset. So, for example, if the first column is numeric, and the second column is logical, and the third column is a factor, etc. And so the call class is a vector, which is not required, but it tells read.table what the class of the data is for each column. Nrows is the number of rows in the dataset. This is not required, but it can be used. Comment.char is the character string that indicates what's the comment character. So the default, for example, is the pound symbol or the sharp symbol, and anything to the right of that symbol is ignored. It's the comment character. So you can specify other characters to be comment characters, and the lines of the file that begin with that comment character will be ignored. Skip is the number of lines to skip from the beginning. So sometimes there may be some header information or some non-data region at the beginning of the file, and you want to skip right over that. And so you can tell the read.table function to skip, the first 10 lines or the first 100 lines, and then only start reading data after that. The last argument is strings as factors. This defaults to true, and the idea is that the question is whether you want to encode character variables as factors. So by default, anytime our read.table encounters a column of data that looks like it's a character variable, it will assume that what you mean to read in is a factor variable. If you don't mean to read this in as a factor variable, then you can set strings as factors equal to false. So for small and kind of moderately sized data sets, and as computers kind of get better and better every day, the definition of small and moderate is kind of growing. But you can use read.table usually without specifying any of the other arguments besides the file name. So you can say read.table on, say, foo.txt. So this is just the name of the file, and it will automatically take care of figuring out what the classes of the different columns are. It will figure out how many rows there are, etc. So you don't have to specify any of that information if you don't feel like it. And then this will return an object here that I call data, and that will be a data frame. So it'll automatically skip any lines that begin with the comment symbol. It will figure out how many rows there are, and again, it'll figure out what type of variable is in each column of the table. So you can tell R all these things, and if you want to, and the reason you might do that is to make it run faster and more efficiently. So with small and moderate-sized data sets, there's usually not much advantage to doing that because it'll be pretty fast and pretty efficient as it is. The read.csv function is identical to read.table, except for the key difference is that the default separator for the read.csv function is the comma, whereas the default separator for read.table is a space. So read.csv is useful for reading CSV files. These can usually so that stands for comma separated value. It's usually something that you get from a spreadsheet program like Microsoft Excel or something similar to that. So CSV is a very common format that most spreadsheet types of programs will understand. The other thing that read.csv specifies is that it always specifies header to be equal to true.